Good day, everyone. Welcome back to my channel, and thank you for the support thus far. If you have not subscribed, kindly subscribe, like, drop your comments on what you want for the next video. It will really be appreciated. Thank you. All right, so today we're talking about functional group homologous series. Functional group and homologous series. So functional group, we're starting with functional group. What is a functional group? A functional group, I would like to call it something like an ID card, an identity card for a family of organic compounds. So there are various organic compounds, and so we have different families. Those compounds are divided into different families. They are grouped into different families. So those families are like that because they have something in common. So that particular thing they have in common is the functional group. So a functional group is an atom. A functional group is an atom or a group of atoms that is identical to a family of organic compound. So a functional group is that thing that you will see, that identity for a particular family of organic compounds. We have different families of organic compounds. We have alkanes, alkenes, alkynes, and a lot of them. So that particular thing you will notice is that all of them have in common is the functional group. So let me just like give a basic example just for you to understand. So let's say we have a family called A, and in this family we have children like Tolu, Tola, Temi. So you will find out that all of them have TTT in common. So this particular T is the basis for this classification, and hence that will be the functional group. But you know we are talking about organic compounds here, so Tolu, Tola and Temi are not so relevant. Apologies to Tolu, Tolas and Temis. Alright, so basically that is what functional group is all about. Now, homologous series. Homologous series is a family. That particular family that we're trying to group is the homologous series, a family of organic compound. And homologous series have various characteristics, those things um, that will make you classify something as this is belonging to this particular homologous series, or that will make you say that okay, this is a homologous series, this is another homologous series. So basically, homologous series are families of organic compounds. So what are the characteristics? The characteristics of homologous series. The first one, the first one is that if you have any compound in a particular homologous series, let's say you have 10 compounds in a particular homologous series, all of them have the same method of preparation. They have the same method of preparation. So they have similar method of preparation. That means that you will prepare all of them in the same way. There will be slight differences such as temperature change and all, but then you would have a general method of preparation for all of them. So for a particular family, let's take alkanes for example, it will have the same, alkanes generally will have the same methods of preparation. So another thing that is unique to homologous series is that they have the same general formula. They have the same general formula. That means there is a particular formula that you can use to keep getting other formulas of each successive member. So, for instance, for alkanes, the general formula for alkanes is CnH2n plus 2. So for alkanes, we have CnH2n plus 2. All of them like that, they have formulas that are peculiar to them that you can use to get the next member. Also, another thing that is peculiar to all of them is that the same they have similar chemical properties. So alkanes or any other homologous series, they have similar chemical properties. The properties of one homologous series will be different from another. They might have slight differences, but then generally you can just say that they have similar chemical properties. You will notice that a particular member of alkane is also exhibiting the same thing that another member of alkanes are also exhibiting. Do you understand? So basically, another thing that you would notice in homologous series in families of organic compounds is that they have a CH2, they have a CH2 unit difference. So the first member and the second member, the difference between each of them will be CH2. First member, second member will have CH2 as the difference. This and this we have CH2 as difference. First and third will not have CH2, but between one and the next, the difference will be CH2. And for instance, now the first member of this family will have N to be equals to 1. And so if N is 1, we have C. We don't really write 1 in chemistry. So the N is 1, you leave it out. Then H2N plus 2. So H 2 times 1, 2 plus 2, that's CH4, which is the first member of the family, and that is methane. So because we said that the difference between the first and the second is CH2, so that means that when you add CH2 to the first one, you will get the second one. So C plus C, we have C2H6. That will give us the next member, which is ethane. So you can continue like that, keep adding CH2, and you keep getting the next member. So that is all about functional group and homologous series. So these are the characteristics of homologous series. They have the same methods of preparation, they have similar general formula, they have similar chemical properties, and they differ by a CH2 unit. And for functional groups, I told her that it is something that you will see, something that you will notice. It can be an atom like oxygen, and it can be a group of atoms like OH that is identical to a particular homologous series, to a particular family of organic compound. I hope that we understand. Thank you for watching. So if you have any questions, drop them in the comment section. And if you have any requests for another topic, drop them also in the next session. Thank you.